Welcome back to our geometry series. Today we are up to section 7.2 where we will be looking at the area of parallelograms and triangles. Here we have a polygon. And let's specify that the opposite sides are parallel, so we end up with a parallelogram. And that leads us to theorem 84. The area of a parallelogram equals the product of the length of a base and its corresponding height, or area equals base times height, which looks familiar. So in this case, we can call this part here the base. However, we need to be careful about the height. The height is always perpendicular to the base, so it must be drawn like this. We don't look at the side of the parallelogram, we have to look at the true height, which is always perpendicular to the base. So for example, if the base was 10 and the height were 7, and area is equal to base times height, that would be 10 times 7, or 70. And if we had units, these would be square units. Next, let's cut this in half with a diagonal across the parallelogram and add some points, A, B, and C. Let's ask the question, what is the area of this new triangle, triangle ABC? Well, we just cut a parallelogram in half, and we know how to find the area of that. And that leads to theorem 85. The area of a triangle is equal to 1/2 the product of the length of a base and its corresponding height, or area equals 1/2 base times height, which makes sense. We're just cutting the parallelogram in half, so the area would be half. So the area of triangle ABC would be equal to 1/2 times the base times height, the same base and the same height. So we end up with 35. Next, let's take a look at an equilateral triangle. Each angle is 60 degrees, and each side is the same. Here, the side is just labeled as S. If we draw the height, we end up with a 30, 60, 90 triangle. So the height of this triangle will be the side times √3/2, based on our good old 30, 60, 90 triangle theorems. So the area of this triangle will be 1/2 of the base, which is S, times this height value that we have here. So the area of an equilateral triangle is S squared √3/4. This is kind of a weird formula to memorize, but it is a good shortcut if you need to find the area of an equilateral triangle. Next, let's look at a rhombus. Remember, a rhombus is a quadrilateral where all 4 sides are the same. Here we've denoted the side length as S. Let's draw in the diagonals of this rhombus. So we ended up just gluing 2 triangles together, and we know the area of each triangle is 1/2 the base times the height. So with some magic and formulas, the area of a rhombus is equal to 1/2 times diagonal 1 times diagonal 2. So as an example, let's say diagonal 1 is 14 and diagonal 2 is 10. The area of this rhombus will be 1/2, or 0.5 as shown here, times 14 times 10, or is equal to 70. Let's turn over the whiteboard and do some examples. All right, we're going to start with a parallelogram up here. Something like this, similar to what we saw in the slides. I promise these sides are parallel. We'll even put the little marks to show that we know what we're talking about. Parallel and parallel. And then we're going to draw a perpendicular height. Wow, that is a terrible line, but it is perpendicular. And the base of this parallelogram is 11 centimeters, and the height is 5 centimeters. So what is the area of this parallelogram? Well, we know the area is equal to base times height. So the base is 11, and the height is 5. So the area of this parallelogram is 55. And just like in the slides, we're going to take this and make a triangle right here. And another triangle right here, right? So we've got a smaller triangle and a bigger triangle. And we're going to label these ABC again, ABC. So what is the area of this larger triangle here? Well, it's the same as this large triangle. And we know the area of the entire parallelogram is 55. So the area of this triangle, and we'll say the area of triangle ABC is going to be equal to 1 half the base times the height. The base stays the same, which is 11, and the height stays the same, which is 5. So we'll write this out as 1/2 times 11 times 5, and we'll end up with half of this value. And this is equal to 27.5. Now, we have units of centimeters, so this should have been square centimeters, and this would be square centimeters. I'm hoping I can squeeze in the next example down here. I'm going to draw a rhombus as best as I can, like this. And we're going to do the dashed lines for the diagonals, like this. And we'll put some letters in here. F, A, R, and M. So we have rhombus, farm, quadrilateral, farm. Diagonals are AM and FR. So let's just let's put some givens down here. We're going to say that FO is equal to 3.5 and AO is equal to 3. Oh, there's an O right there. O is in the center, sorry. So FO is 3.5 here to here, and AO is 3 from here to here. What is the area of the entire rhombus? Well, remember, let's squeeze it down here. The area of the rhombus is equal to 1/2 of diagonal 1 times diagonal 2. So we need to find this length times this length. Well, FO is 3.5 here to here. And we learned from our previous sections that when you take the diagonals of a rhombus, you bisect each other. So FO and OR are equal to each other. So this is 3.5 and this is 3.5. FR, which we'll just call D1, FR, and AM will be D2. So FR from here to here is 7, and AM from here to here is 6. So now we have our two diagonals, and we need to take 1/2 of that. So we are just barely on the screen. We got all this room over here. So the area of this rhombus, that sort of says rhombus, is 1/2 times D1, which is 7, times D2, which is 6. And 7 times 6 is 42. So the area is 21. All right, let's clean this off and do another example. All right, we're going to draw a triangle up here in the corner like so. And this is a right triangle. And I'm going to draw a dotted line down here that is perpendicular to this side of the triangle. And we'll put some labels on here like T, A, K, and this point here is Y. And we'll put some givens over here. We're going to say that TA is equal to 10 and AK is equal to 24. And we want to know the area of triangle TAK. All right, so TA is 10. Let's just write that down, 10. AK is 24. What is the area of TAK, the larger triangle here? Well, because we have a right triangle, we have a base and the perpendicular height. We're just going this way. It's still considered the height, even though it's going down, not up, but the base times the height. So the area of this is going to be equal to 1/2 the base times the height. And in this case, the base is this across the top, 24, and the height is 10. So that's equal to 1/2 of 240. Need a new marker soon, which is equal to 120. And we're going to erase some of these values and try a different problem. Let's say AY is 15 and AK is 25, oh, it's probably new marker time, 25. We want to find the area of triangle, so the area of triangle AYK. So this triangle. So in this triangle, this would be the base and this would be the height because they're perpendicular to each other. So YK, we need to find out what that is because we already have the height. So how would we find this third leg of a triangle if we have two of them? Well, we have a right triangle, so this side squared times this side squared is going to equal that side squared. Let's just jot that down. So YK squared plus 15 squared, this other side is going to equal the hypotenuse squared, 25 squared. So this would be YK squared plus 225 is equal to 625. So we're going to subtract 225 for both sides. YK squared is equal to 400. Well, that's a nice convenient number. So if we take the square root of both sides, we are still on the screen. YK with my terrible marker is equal to 20. But that's not really what we're trying to find. We're trying to find this, the area of this triangle. So let's jot in that 20 here. So the area is 1/2 the base times the height. And we have just enough room down here, right? 1/2 the base times the height. So that's 1/2 the base, 20, oh boy, times the height, 15. So I'm going to do a little bit of math here and just take half of 20, which is 10, times this, which gets us to just barely on the screen of 150. That's it for today. We'll see you next time.